Okay. All right, so we're gonna do 6-1 half or 6-2 half today, half tomorrow. It's gonna be really similar to 6-1. You're gonna notice what we started with confidence intervals last week. The biggest difference now is in all the problems we did last week, we knew the population standard deviation. Now we will not know the population standard deviation, and that means we're no longer allowed to use our Z distributions with our Z scores on our chart. We're gonna have a different chart and set of information that we're going to use to calculate those margin of error and the confidence intervals that we talked about before. Okay, this is not on your paper. Actually, let's just kind of go to the next slide here. This is what you need. Okay, so instead of a Z distribution in this lesson, we're going to be using a T distribution. Your T table is the next table in your purple packet. I think it's table number 5, if you look at that, okay? And we don't have to worry about one side's positive, one side's negative. It's all just on one page, so there won't be as much flipping back and forth. The T distribution, actually, let me flip to the next page so you can see it, has a lot of similarities to our standard normal curve. So it's still bell-shaped. Area under the curve is still equal to 1. The mean, median, mode are right in the middle at the top of the peak there. But you'll notice the standard normal curve, which is one we use for Z, that's the blue one in the picture here. And then our T values, it's going to have bigger tails at the end. They're like a little fatter on the sides. Hello? So on each strand. Okay. All right. Well, maybe. Okay. All right. You decide how much we need. Okay. All right. How wide the tails are at the end is going to depend on something called, you'll see it says DF here, degrees of freedom. Degrees of freedom is actually your sample size minus 1, if you want to circle that on your paper there. And you can use it for a lot of other things in higher level statistics. All you need to remember for now is degrees of freedom is n minus 1, and that's it. The bigger n is, the bigger our degrees of freedom are, and the closer this T distribution is going to look to the standard normal curve. The smaller a sample size you have, the bigger these n's are going to be. So what you're going to notice when we start calculating probabilities and things with T distributions is when we're on the ends of the curve, you might notice some bigger probabilities than what we saw before with the Z-scores because those are so much wider on the sides, okay? Like I said, a lot of other similar properties. You've got that on your paper here. Area under the curve is 1. It's called bell shape, but we don't use the word normal. Median, median, mode are all right in the middle. Okay. All right. Finding critical values of T on your chart. So here we want to find a critical value, and they're using a T sub C instead of a Z sub C now for a 95% confidence level when the sample size is 15. So just practicing finding this value on here. So at the very top, bless you, of the T chart, you're going to find a 95% confidence level, which is the one right in the middle, 0.95. And then on the side, you'll notice it says degrees of freedom. So that's a quick little, I don't even know if you'd call it a calculation that you have to do. If my sample size, my n, is 15 in this problem, my degrees of freedom is just 1 less than that, 14. That's all we have to worry about. So we're going to go down to row 14. We're going to go over to a 95% confidence level, and we get 2.145 would be the critical value of T, and you can see that on there. We don't have to worry about positive and negative sides. We don't have to worry about adjusting anything. It's just the number you find in your chart, and that's it. Okay, so for the next one, find a critical value of T for 90% confidence level when the sample size is 22. So if the sample size is 22, we're going to look for a degree of freedom of 21. Okay, then we're going to find a 90% confidence level, which is the second row, we're going to go down 1.721. 721. Okay. If you look at the very bottom of your T chart, you're going to start to notice it jumps around a little bit. It doesn't have every single value here. So let's say you had degrees of freedom of 43. Okay. 43 isn't on here. You're going to pick the degrees of freedom that is less than that number but closest to it. So I would use 40 for my degrees of freedom if it was 43. Even if it was like, let's say my degrees of freedom was 59, even though 60 is closer, I would use 50. We always round down if the number isn't on our chart. Okay. All right. This formula, can I write that down on your paper? Just put it in margin somewhere. Okay. This is actually the same margin of error formula we used with our z-scores before. We've got a few different pieces of notation, but it's the same calculation. So now instead of a critical value of z, you have a critical value of t. And instead of a population standard deviation, which we use the lowercase sigma for that, we have s for a sample standard deviation. That margin of error, remember, is what we calculated and then added and subtracted onto our sample mean to get the confidence interval, which again is the goal, trying to estimate that population mean again here. Okay. I got it. All right. So critical value times standard deviation divided by the square root of n. All right. So first thing we're going to do is just practice calculating that margin of error. Here I have a level of confidence of 95%. I have a sample standard deviation of 5. I have a sample size of 16, which means I can also say my degrees of freedom is 15. And then I'm also going to need a critical value of t. So we're going to look that up. We're going to find 95%. We're going to go down to 15 degrees of freedom. And that gives me 2.131 is my critical value. Margin of error, critical value, times the standard deviation divided by the square root of n. And just plug it in. 2.131 times 5 over the square root of 16. And I get 2.66 approximately. Okay. Okay, so for number 2, can you tell me what the critical value of t for that one would be? 98% level of confidence. My sample size is 9. So remember, we're just going to look up degrees of freedom 8, one less than that. 2.896. That sound good? And plug it in. 2.896 times sample standard deviation here is 4.7 divided by the square root of 9. Easy little calculations. About 4.54 if I give it 2 decimal places for that one. Okay. Any questions there? Nope. Okay. On the back, you have this, and again, we've got that margin of error formula written. These are pretty much the same steps that we used last week to calculate the confidence intervals when we had our normal distribution. Only difference here now is because of that standard deviation, our variables are changing slightly and we're using our other chart. Okay. Let's see. So significance level will be given to us. We either have to calculate our standard deviation and our sample mean if it's not given to us, or just use what's given to us. We could also calculate the degrees of freedom by taking n-1. We're going to find that margin of error, and then in the last step, to estimate the population mean, remember that's our goal here always, and that's going to be in our interpretation every time when we list it. We're going to take x bar, whatever our sample mean is, and add and subtract on that margin of error. That will give us that confidence interval that we're looking for. All right, so let's do an example, and you can see what it all looks like put together. You randomly select 16 coffee shops and measure the temperature of coffee sold at each. The The sample mean temperature is 162 degrees Fahrenheit with a sample standard deviation of 10 degrees Fahrenheit. Construct a 95% confidence interval for the population mean temperature of coffee sold. Assume the temperatures are normally distributed and interpret your results. Okay, we still want to check at the beginning that at least either our population is normally distributed, which it is here, or our sample size is bigger than 30 because they're telling us everything's normally distributed. We're good. The next thing that I always look for in these problems, because when it comes to quiz and test days, you're not going to know. It's not going to say use a Z chart or use a T chart. You're going to have to figure that out from the context of the problem, is we want to look at our standard deviation. The standard deviation is 10 degrees Fahrenheit, and they're telling us it's a sample standard deviation. That's a key word here, okay? If it didn't say sample standard deviation, it would either say population standard deviation, or it would say all of the values give this standard deviation, all or every. We know that means population. Because it's a sample, that tells me it's going to be a T, okay? If it gave any hint that it was coming from a population, it would be Z instead. You would use your other chart. Okay, as soon as I know I'm going to use T, what can I get here? I know my sample size is 16, and because it's a T, I'm going to need degrees of freedom, which is 15. Sample mean, X bar, is calculated for us. It was 162 degrees Fahrenheit. Sample standard deviation, S, is a 10. Level of confidence is a 0.95. That's all just given from the problem. And with all of that, I can also get my critical value of T. So degrees of freedom, 15. Level of confidence, 95%. I think this is one we used already. 2.131 is that critical value of T. Once we have the critical value of T, we calculate the margin of error. Critical value times the standard deviation divided by the square root of n. So I get 5 point, I'm going to give it 1 decimal place because that's what they're rounding to, 5.3. You may in Math Excel be asked to interpret what that margin of error means. Everything in this problem is temperatures. So this is 5.3 degrees Fahrenheit is the margin of error, which means the estimation that we're going to make is going to be within, hopefully, 5.3 degrees of whatever the actual population mean is. That's how close we're going to be within that many degrees. Okay, now to get my confidence interval, X bar plus and minus E. X bar is 162 plus and minus my 5.3, and we have a confidence interval. On the high end, that's going to be 167.3. On the low end, 156.7. And again, you could label both of those degrees Fahrenheit if you wanted to. Okay. And then often we're going to ask to interpret here. Okay, so there's 2 different ways that we can say this. We can say either A, we're 95% confident, or we can say, I'll write it this way, there is a 95% probability that the population mean, that's what we are always estimating with these confidence intervals. Make sure that's part of your interpretation. Of all coffee temps is between those 2 temperatures, 156.7 degrees Fahrenheit and 167.3 degrees Fahrenheit. Okay, so really similar to what we did with the Z factors before. Okay. Any questions on that? All right, the last example we're going to do today is actually 2 little slides that are on your paper here. It's all together. The difference between this problem and the one that we just did, and the one that we just did, you were given a sample mean and you were given the sample standard deviation. Not all of the problems are going to give you those pieces of information. You may have to calculate them from a data set. So we're just going to review how to do that. We're going to collect our own data set for this one. For our little collection process, we're going to do a fun little quick activity. You need just like a blank scratch paper, anything you can just jot some words down on, okay? We're going to take 1 minute, and we're going to see how many states you can write down in 1 minute. And that number is come up on the board. That's going to be our data set. All right, so just a little scratch paper, a margin somewhere. Doesn't have to be anything official. Okay. I'll get my timer out. Okay, so you need to write down the whole word, not just the abbreviation. Okay, I know, that's what you were thinking. All right, whole word as much as you can in 1 minute. As many states as you can. Ready? Set? Go. $30 seconds left. Three, two, one. All right, finish writing the state you were on. Okay, put your number up on the board where it says number 1. Count them up. 20 states was our winner during the first period. Just under number 1 there.
Yeah, no, we don't know. I was like, I'm not gonna get the small ones first and then got to the bigger ones.
Ooh, 21. All right, everybody got them up there? Okay, so what you need to do now, if you don't want to write down all the numbers, that's okay. But either in a spreadsheet or in your calculator, you need to put all these numbers, and you need to calculate the sample mean and the sample standard deviation. So remember how we did that with the calculator? It might be the easiest thing to use right now. Is put them all in list 1, and then hit stat, calc, and then 1 variable statistics was the option that we picked. So 1 variable statistics after you get them all in there. Make sure when you pick your standard deviation, remember there's 2 of them, it's a sample standard deviation. So we're picking the x, or the s of x instead of the little sigma sub x there. All right, make sure you pick that option off of the list. And then from there, you should be able to answer the rest of the questions on your packet. Okay, so I'll give you a minute. I'll put answers up on the board in a few minutes. Try it, see what you can do. First slide here. I got you can see with the dot plot, it's almost starting to look like a normal distribution there. If we had a larger data set, we'd probably see more of that curve. Everybody get the sample mean and the sample standard deviation, okay? the calculator. Sample mean's not too hard to calculate on its own. The standard deviation is the one that would take a while if we didn't use technology. Any questions on that stuff? No? Okay, and then on the next slide, it does say on here it's a 95% confidence interval that we're finding, so you need that information for the next bit. Degrees of freedom are 24. If you have a 95% confidence level, your critical value is going to be 2.064. Use that in the margin of error formula, you get a margin of error about 1.16, so it'd be 1.16 states. That's what we would be within. Add and subtract that onto my sample mean, and we get a confidence interval of 15.68 to about 18. So you can either say we can be 95% confident, or there's a 95% probability that the population mean of states that we can name in a minute are between 15.68. Tomorrow we'll do a little more practice with this, and that'll finish up 6-2. Wednesday we're going to do 6-3. It's a one-day lesson. Thursday is a Math Excel work day for you, and Friday is an individual open note quiz over what we're learning in chapter 6. So 6-1, 6-2, 6-3 on Friday. Individual open note quiz. Okay? All right, I'll do cell phone lotto. Everything I pass back to you today, you can keep. The rest of the period is yours to work. 6-1 is due tomorrow, 6-2 due on Thursday. Number 19 is my cell phone lotto winner. Okay.